na- nakita niyo na yung schedule ng midterm, no? Excuse me.
Opo.
So, meron ba kayong namin ngayon? Numerical? Research methods? Elective? Combustion? Ano pa ba ang sa day? Ay, hindi pa pala. Okay, so schedule ng ating exam is October 17, 1:45 to 3:45. At least, mauna siya. Kasi, yung dati, pag pangalawang exam siya, nalulugaw na ba yung isipan? Tapos hindi na nakasagot. Pero anyway, good luck. Good luck. And kung makita niyo, ay wala naman kayong exam ng October 18, di ba? Friday. So, kasi ang schedule naman nun, machine design to, tsaka vibration. Wala naman kayo nun. May thermodynamics ba kayo?
Wala po.
Tapos na po.
So, pwede tayong mag-check ng papel sa October 19. Mag-request pa ba kayo, sir? Wala munang klase. Uso ba sa inyo yung ganun? Okay, so wala nagsasabi. October 19 is Saturday. So, good luck. Galingan nyo. Sinasabi ko na, mahirap yung exam. Sin talaga. Again, sa terms, sa identification, madali naman siyang identify kung ano yung mga for identification. Kasi dun sa lecture na binigay ko is, tingnan nyo lang alin ba yung mga naka-bold letters dito. Tapos, ano pa ba? Konti lang enumeration. Then, merong part na maghahanap ng sentro. So, yung paggawa ng sentro polygon, yun. Then, sa mobility, check lang kayo sa internet. Mag-compute ng mobility. Baka makita nyo din yung figure na nakita ko. Then, velocity analysis na. So, sa velocity analysis, resolution composition method, instantaneous axis of velocity method, tsaka relative. Kasi yung centro method, masyadong matagal eh. So, ngayong ating session ay mabilis lang. Pagsasample lang ako ulit ng velocity analysis, send na lang po para hindi na kami naghahanap. Joker ka, ang galing mo. Ano sabihin ka? So ngayon is mabilis lang yung ating session, yung ating class. Magsasample lang uli ako ng velocity analysis using relative velocity method. And kung paano ko siya gagawin, parang ganun lang din naman yung gagawin nyo dun sa exam. Okay? Patay. Mabilis siguro, 8:30 tapos na tayo. Or 8. Aga naman. Depende sa chika. Bubuhay. Hello? Nagfe-feedback ba? Okay. So, naririnig niyo ba ako ng ayos? Okay. Okay. Good morning. Let's start. For today's session, this will only be for the relative velocity method. How do we do that? First, syempre, dapat we have given angular speed. What happened? So the angular speed is given at, for example, is on 250 RPM. And it is turning at Q2A. So Q2A is our crank. And Q2A is, for example, 8 centimeters in length. So to compute for the velocity analysis of this figure, so we have point A, point P, point B, point C, and point D. Let's determine their velocities using relative velocity method. Again, okay, later. So for relative velocity method, let's convert this angular speed into linear speed. So computing for the velocity at A, we have the circumference times the angular speed, whereas the circumference is equal to 2 pi r. And if our A is turning in a perfect circle because it is a crank, meaning point A can trace a circular path, meaning the circumference is pertaining to the path that point A travels to, and Q2A can be regarded as our radius. So R is equal to Q2A, which is equal to 8 centimeters. So by computing, velocity A is equal to 2 pi times 8 centimeters times 250 revolutions per minute, whereas one circumference is equivalent to one revolution. We have to cancel units, and we will have 500 times 8, 4,000 by centimeters over minute. Again, during the exam, it is already stated in the problem that we will use only whole numbers. So you will have to multiply pi, you will have to divide the denominator. So whole numbers, round up to whole numbers. Then, we will make a velocity scale. So let's say for every 1 centimeter, we have 1000 pi centimeter per minute. And when we multiply the velocity A with the velocity scale, cancel unit, cancel 1000 pi, we will have 4 centimeters. Then, let's draw the 4 centimeters here. Should be perpendicular. Okay. And this is velocity A. Okay. Since we will be using relative velocity method, we will have to pick a location on where we would want to put the velocity polygon. So let's say I want to put it here. So this is the small q. First, I will have to copy the velocity A to this small q. I will have to first make reference line. Let's connect Q and A. Then let's make a perpendicular line that will intersect our small q. Then we will make 4 centimeters here as computed earlier for velocity A. Then at the end, let's put a small letter A. Yeah. Now we now have the start of our velocity polygon. Next, we have to determine velocity at, since we have P, we can start with B first. So for B, uh, it is connected to the ground. So we can have Q and B. Let's make a line here. Then let's make a perpendicular line going to Q. Oh. Okay. Then we still don't know how long velocity B is. So another help will be using another reference point. So we have A. Let's make a line for A and B. Then we will have a perpendicular line here going to the small a. And their intersection will be our small b or velocity b. And this is now velocity b. Then for velocity c, let's have q and c. Let's make a line. And let's make a perpendicular line going to q. Then let's make a perpendicular, since C is connected to B, let's make a perpendicular line for B and C. Let's connect it to the small b. Then their intersection will be the end of velocity c. So this is now c. Then what more? We have d. D is a slider, so its velocity is parallel to the ground. So we'll just make a vertical line here, but we still don't know how long it is. Then it is connected to C. And let's just make a line here, C and D. Then make a perpendicular line that will intersect C. Then the intersection will be point D. And this will now be velocity D. Then lastly, we have point point P. Point P is in the middle of A. It's not exactly in the middle, but it is in between A and B. So meaning, in the velocity polygon, point P is somewhere here between A and B. So we will use ratio and proportion. First, let's measure how long A and B is. So we will have the proportion AP over AB. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's say 14 centimeters. Again, I'll check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then AP is 1, 2, 3, 4.2. Check. 1, 2, 3, 4.2. Then let's go to the small or the polygon. How long? We will have also the proportionality AP over AB. Let's measure AP. 1, 2, 3.3. Again. 1, 2, 3.7. Then this is unknown. We will have to determine it using ratio and proportion. And we can have 4.2 over 14 is equal to 3.7. Let's say it's X or AP. Now, calculator. I have a calculator. So the answer is 1.11. 1.11, let's plot from A, it's 1.1. So it's around here. So this is point P. So we will just connect Q with point P. And this is now the velocity of P. We now have determined the velocities of A, B, C, D, and P. Then Let's write it down. So we have velocity A. We already computed A. So we have velocity P, velocity B, velocity C, and velocity D. Let's measure. Velocity P is 1, 2, 3, 3.9. Then for B, it is 1, 2, 3, 4, 4.9. 1, 2, 3, 4. For C, we have 1, 2, 3, 4, 5, 5.1. Then for D, we have 1, 2, 3, 4.2. This is now our length of the vectors. We will now multiply it with the velocity scale. So our velocity scale is for every 1 centimeter, we have 1,000 pi centimeter per minute. Now we will have Vp at 3,900 centimeter per minute. We have Vb at 4,900. Vc is 5,100. So there's pi here. And Vd, we have 4,200 pi centimeters per minute. So this is velocity analysis using relative velocity method. Now one more try using the same figure, but if the location of Q is here. Let's check if we will get the same answer. We might not get the same answer because I'm using a digital ruler, but I think it should be close. So first, let's make velocity A, and velocity A should be perpendicular. So let's make a line here from Q to A. Then let's make a perpendicular line going to Q. And it should be 4 centimeters as computed. 1, 2, 3, 4. So this is now velocity A. Then let's go with B. So B is connected to the ground. So this is the same line. So let's just use this line. And let's make it go to the Q. Then A and B. Let's make it intersect at the small a. Then their intersection will be the end of D from Q. This is now velocity B. Then for C, since C is also going to Q, let's just make a perpendicular line here. This one. Okay, so that's Q. Then for Q and C, let's make a line here, then intersect at B. Then their intersection will be point C. This is now velocity C. Ba't ganun? Nagpuputol-putol. Then velocity D is a slider, so it is going down. And we'll make a line for C and D that will intersect small c. Then the intersection will be point D, velocity D. Then for point A, it is the same uh, proportion. So we can use the same proportion earlier. So this is P. Then we'll make a vector at Q going to P. And now we have velocity P, velocity B, velocity C, and velocity D. Okay, let's just measure. Velocity P is around 4. For B, we have 1, 2, 3, 4, 4.9. For C, we have 1, 2, 3, 4, 4.9 din. 4.9 ba to? 5. Then for D, we have 1, 2, 3.9. Then, let's multiply it with our velocity scale times 1,000 pi over 1 centimeter per minute. We will have BP, VB, VC, VD at 4,000 pi. Excuse me. Then we have 5,000. We have 4,900. And we have 3,900. If you will look at our previous computation, they are not exactly the same, but they are close. So during exam, this will not be the case with you because I am using a digital ruler. So there are more inaccuracies here in using a digital ruler than an actual ruler. But still, we have tolerance. But of course, I think because as per instruction, we will use whole numbers. The difference will be not that much. So if we will round to whole numbers, so if it's one, for example, it's 500.75, we will use 501. If 500.13, we will use 500. So that's why my instruction is to use whole numbers. But again, since you will be using an actual ruler, the difference will not be that great. And if you will look at the polygon, they look exactly the same. And the discrepancy is only because I am using a digital pen and digital ruler. But essentially, the if you will look closely, again, regardless of where you would put the initial small q, the answers will be the polygon will be the same. Okay? So as mentioned, this is only a quick session. This is only for the demonstration again of the relative velocity method. So I would like to open up the class for any question for any methods starting from resolution and composition or starting from mobility. So any questions before our midterm exam? Any questions for the whole midterm period, midterm exam? Okay, if there are no questions, good luck on your exam. See you again in 2 weeks. And good luck on all your exam, not only on my exam.
Yes, sir. I think it's also down. Yes, sir. Yes, yes. Yes, sir. Yes. My answer is yes.
Tapos na tayo. Ano ba gusto niyo mangyari?
Thank you po, sir.
Gusto niyo ba magkanta?
Thank you po.
Thank you po, sir.
Thank you po.
Thank you po, sir.
Thank you po.
Thank you po.
Hello?
Ano, gayak na kaya?
May mga naliligo pa. Si Sarah ililigo. Tatay, may alam na naman bago si Sarah.
Ano?
Kinuha calculator. Acha, 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 acha. Anak mo. Sino, pakita mo nga ng bagong natutunan ni Sarah. Nasaan na? Nasaan na yung calculator? Sarah, Sarah! Ah. Ano? Eh, alam ko yun. Ang anak ko mga nagagay mga 2 years old eh. Sabi nga,
Ang bobo naman yan, hindi niya alam ang cellphone.
bata yan. Ay, sorry na. Napabalik ako. Wala.
Okay. Asa ako maya. Hello, Hans.
Sir, ako po yung present. Biglang nagip kanina sa screenshot.
Oo nga. Present nga kayo, tapos na yung klase. Nandito ka pa din.
Hindi po, sir, ako po yung na-adjourn ay nung nagsimula na po.
Okay lang.
Thank you po.